So thanks for attending NetflOSINT. This is taking an often overlooked data source and operationalizing it. So we're gonna explore things from to a certain level, kind of like beginner network forensics or maybe network engineering, and go through an odyssey of what we could do with that we could run into possible OSINT scenarios. So about me, I'm the founder, principal instructor, content developer at the OSINTion. I also work in threat hunt and threat intelligence at Mercari. I wrote a book, Practical Social Engineering. I have a few copies for sale out in the coffee area after the presentation. I'll also have a coupon code for you. Beyond that, I've got some certifications. I like to do research, and I've been awarded 2 black badges from TraceLabs and 1 for winning the 2017 Social Engineering Capture the Flag at DerbyCon. So why this talk? Well, beyond what those words on the slide say, why this talk? I lost my job in December of last year, and I was unemployed for a few months. The OSINT well kind of dried up pretty quickly because, I mean, people just weren't hiring remote OSINT work, at least in the US. So that forced me to kind of pivot into something else. So how do I go about this? Well, I immediately looked at threat intelligence and other forms of DFIR. With that, in some of the interview processes that I did, I had to do a technical assessment and a report. And there was a common theme that I saw there. The common theme was they're giving me a bunch of passive DNS data, which, if you do OSINT, you know that that's a treasure trove and lots of fun is to be had there. But then they also would hand me a CSV of Netflow data and say, make sense of this. Well, how do I make sense of this? This is kind of the culmination of working through those steps and that research to be able to progress in the interview process. That's, in full disclosure, that's what this is coming from. But with this as well, you know, when we think about network forensics, we immediately think PCAPs because, you know, how's the phrase go? PCAPs or it didn't happen, right? That's true. We may also think about logs, but each of those have their own merits, but none of them provide a singular solution across the board. So, you know, I'm not going to tell you that logs are garbage. What I will tell you is they can be corrupted, they can be overwritten, they can be time-stomped, they can be misconfigured, if even configured, and so on. With PCAPs, I really don't have a debate against PCAPs, aside from sometimes those file sizes can get really big really quick. But, you know, with that, how many devices can natively generate Netflow or IPFIX, but we never really use it, right? You see it sometimes in marketing materials, but that's about it. Like, show of hands, who in here actually routinely makes use of Netflow data as part of your blue team or blue team adjacent position? Okay, we got a few waves of the hand, so they kind of do. So not many. So hopefully this can change some thought processes with that. So the agenda for this, I'm going to start out with a very rudimentary basics of network forensics. Then we're going to talk about what is Netflow. We'll compare PCAPs to Netflow. We're going to, I struggle with whether the correct word would be extract. I'm starting to think the better word might be infer Netflow from PCAPs. Then we'll go into analysis, and then I'll talk about logical next steps, and that's where the OSINT perspective comes into play. So starting out with network forensics. When we talk about network forensics, again, that's logs, PCAPs, and Netflow. So definitions here, I'm not going to read the definitions, but basically, in that regard, logs are a data source. They provide us a data point. Looking at the evolution between data, information, and intelligence, data is an irrefutable fact or statistic. It is a chronicle of an event having occurred. Can we all agree that that's what a log is? I might disagree on the word irrefutable, unless you want to use blockchain. Anybody that's got their buzzword bingos, I hope you're not playing a drinking game. Anyway, that being said, for the most part, logs are irrefutable. So it is a memorialization of an event that occurred at a particular time, and there are things that could happen that could affect that. Packet capture, that's the collection of all the network data of a particular time period or transaction or whatever to that effect. And then Netflow, that's metadata. In the US, when people, especially outside this industry, hear the word metadata, they immediately think NSA and Edward Snowden. Metadata is data about the data. It's data that describes the data, right? And basically, it's going to help us to understand what the data is already telling us. When we talk about images, we've got metadata that tells us GPS location, altitude, that kind of stuff if we're talking about like EXIF, right? So this is really no different, except you're not going to get a Latin long out of this. You're going to need some API connectivity for that. But, you know, with Netflow, it gives us a really good vantage point to examine east-west transactions, which would be lateral movement within a network, or north and south, which would be your ingress and egress. So that would be something coming in or data exfiltration. So pros and cons with this. Logs are great until they aren't. And that speaks to not configured, misconfigured. Could be deletion or corruption. It could involve time stomping. It could, they're going to vary in file size, right? Because something I tell students in the OSINT world is, if you collect it, you're obligated to secure it. And while you may think you've got a massive external hard drive, I mean, I've got a 4 terabyte hard drive right here, but with a few PCAPs, I can fill that up, right? Same thing with logs. It would take a lot longer with logs, but storage is at a premium. And within this industry, we tend to hoard things all the time. Don't even get me started about OSINT hoarding, the people who want to collect everything about everyone all the time and keep it forever. They're really good to know if you're in the middle of an investigation in a pinch and you need some additional data, but the liability that comes with that, and I mean, for people in more executive positions, even in the US, the 4 letters of GDPR still terrify us. Because, I mean, it can hit us where it hurts, right in the checkbook. So with that, the file size, the variants, and then, I mean, they can be in different formats. If only there were a unified format for logs to be stored in with like a set of fields that everything could use, and we would never have to write another regular expression again. Boy, you talk about utopian dreams. Anyway, PCAPs, they are excellent, and they are also considered universal truths because PCAPs or it didn't happen. They do show the complete picture with exceptions. Encrypted protocols can be that exception. If you don't have the means to decrypt that stream, you can see this host is talking over HTTPS, but if you cannot decrypt that stream, you are basically in a foreign country with no idea of the language. You are sitting there listening to adults talk on the peanuts. Wah, 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 wah. That's what you're hearing. Nothing can be assembled from that. Also with PCAPs, you have the larger file size. If someone moves a 3 gigabyte file, guess what? Your PCAP is at least going to be that size. You might get some compression, but not a lot. And honestly, something I picked up on it, with the PCAP, it is difficult to natively and efficiently perform statistic analysis. Like, you've got cool things like follow stream. You've got all the filters within Wireshark. Like, by no means am I saying don't use PCAPs. I'm not saying don't use Wireshark. They are both great, but you can amplify it, right? So with NetFlow also in some cases adjacent to that would be IPFIX. It's already native to many routing devices. It's already there. It's not used in favor of logs or PCAPs. Decision makers will say, we don't need NetFlow because we're already logging this and we're storing PCAPs if it meets this criteria. In comparison, it's a smaller file size to PCAPs. In some cases, it may even be smaller than a log. You do have less visibility. I'll admit that 100%. But it is easy to analyze and perform that statistic analysis. That's where it's coming into play. So we'll talk a bit about NetFlow. What is it? It was made for troubleshooting, originally designed by Cisco. And with that, it requires an exporter, a collector, and the means of storage. So big surprise there. There are a variety of versions of NetFlow. As you can see, 1, 5, 7, 9. 5 is the most common, 9 is the second most common. Technically IPFIX is called NetFlow version 10, but it really has nothing to do with NetFlow. So some typical fields of NetFlow. If you're familiar with PCAPs, this really shouldn't look that foreign to you, right? So time, source and destination port and IP, protocol, type of service, and bytes. You may also see octets. You may also see packets, and that'll be sent and received. So the same fields you see in a PCAP, really. So with it, this is basically the same thing that I said before, but it's taking it a step further. In the United States, we have a brand of facial tissue called Kleenex. And you don't, like if you need one, typically you don't say, could I have a facial tissue? You say, hey, could you pass me the Kleenexes? It doesn't matter what brand, right? It's like soda. Give me a Coca-Cola. Most of the time, even if it's Pepsi, they're going to hand you a Pepsi and they know what you're asking for, right? So it's kind of like a brand name associated with it. There are similar products that just have different names, but they accomplish the same thing. And IPFIX, the acronym is IP Flow Information Export. And it's got its own RFC if anyone in here has insomnia and the need to read RFCs. If that doesn't put you to sleep, might I recommend the RFCs associated with SPF, DChem, and DMARC. They have saved me many a nights. BIMI's another good one. So, comparing PCAPs to NetFlow. NetFlow abbreviates the story. NetFlow is the TLDR. It is, think of it like in the terms of report writing. NetFlow is kind of the executive summary. You're in a very small building with an executive and they're trapped in the elevator with you. What can you tell them before the doors open the next time? That's what NetFlow can accomplish. PCAPs are akin to J.R.R. Tolkien books. They're going to spend 30 pages telling you what the trees smell like, followed by about another 90 pages of short people walking around in Middle-earth. I'm not a big Tolkien fan. Sorry. But with NetFlow, you have the smaller file sizes. So if we were making movies about NetFlow, we are not going to have everything broken down into 3 books. We're not going to have a 3-hour movie per book, and then the final book split into 2 different 3-hour movies. We can probably watch it on YouTube in 25 minutes or less, right? Keeping with my quasi-hatred of Lord of the Rings. So with that, the smaller file sizes means it's more manageable. It's going to take up less space. You can more quickly react to it and make a decision. You can very easily import it into your SIM even a CSV. And if it goes into a CSV format, there's a lot of fun things you can do with that. Anyone here interested in data science at all? Playing with like Jupyter Notebook type stuff? So when I hear CSV, I think pandas. Because what can I do with pandas? But it doesn't include the packet contents. Whereas the PCAP, it's going to have everything. You can do file carving from it. If I transfer a file to you via FTP or HTTP, you can carve that out. If you are able to decrypt it, doesn't matter if it's HTTPS, you can do the same thing, right? Which is useful. The stream filtering is very useful as well. But when you've got 100 hosts on a network and they're all very chatty, and you've got 3 days worth of capture in a single file, how do you know where to start? You might have some indication, but what if you're just doing this as a blind hunt? You have no indication of normality, right? Especially if you're a consultant. If you're a consultant and you just walked in the door, the only thing you have to base what is considered normal on, that's based on the truthfulness of your client. And I like to think that clients are usually truthful, but if it's going to make them look bad, I've learned that oftentimes that's not always the case. Just saying. And then you've got the larger file size thing. So let's talk about how we can extract or infer NetFlow from a PCAP in terms of tools and scripts. Does anyone have any ideas of how this can be accomplished just off the bat? No? So we'll get to it. What we need a PCAP, right? Because again, it didn't happen if there's no PCAP. I would like to know about all the PCAPs associated with trees falling in the forest. But anyway, we also need a Linux host with Silk. That's what we're going to use. Optionally, you might need Excel, OpenOffice, LibreOffice, something to that effect, something you can read CSVs or spreadsheets with. You could use a SIM as well. For the demonstration, I'm going to show you using Elk, but admittedly, I'm not the biggest fan of Elk. Elk was just the right price on a 14-day free trial for me to accomplish this. Or you can go my personal favorite route and use Jupyter Notebook with pandas. So to start, I'm gonna talk you through this, and then I've got a video to show you that'll make a little bit more sense of it. But basically, you go to your directory where you have the PCAP, and you execute RWP to flow the path, and then flow out. You tell it where you want it to go, the full path, and then there's your path, CSV file name.csv. There you go. From there, I'm sorry, it's the flow out, and then the other one's RW cut, delimited with a comma, and you feed it all the stuff with an RW file. From there, that's going to generate the CSV. So the first one is going to go from PCAP to RW file type. The second command will take you from RW to CSV. Then from the CSV, you put it wherever you need to go, whether it be Excel, Splunk, Elk, QRadar, I think AlienVault will even do it, or Jupyter, whatever you choose. So here's a populated example. So with this, I'm in my source directory, and I'm going into the subdirectory PCAPs. And I'll tell you, if you want to play with this, if you go to Active Countermeasures website, so Black Hills Information Security's sibling company, if you go to Active Countermeasures website, they have a thing called Malware of the Day. You can download PCAPs from there. That's where this sample PCAP actually came from. So it doesn't matter. You could collect it yourself, but this is associated with a particular threat actor. So with this, we give it the flow out. I put it in that particular directory. It says an RW file. Then I run RW cut with the delimited timestamp format ISO, output path, and there we have the CSV. And then we're good to go. And on that, let's take a look. So this is a pretty short video, like to the tune of 23 seconds. So as you can see, I'm in the malware of the day directory. There's your initial command. So RWP to flow, and then we see right here flow out and the .rw file. It'll take a moment. There we go. And then I flubbed up the command, but it's one of those, I'm not worried about perfection because we all make these mistakes. So really, even though this is a 23-second video, you can accomplish this in little to no time. I would say less than 5 seconds. Because if we go back here, here's where I've successfully ran the command. So we have it, and then at that point, that's when I do the ls, and we have evil os10_1.csv. So we've already, this is the inference. The inference is complete. At this rate, we have inferred Netflow from a PCAP. So that's really all we have to accomplish. There's really nothing more to it. So it's a very easy process to do. I'll say in many cases, the hardest part is actually getting Silk installed. That was kind of a pain in the neck. So now, at this rate, we'll talk a little bit about the analysis methods to this end. And with this, you probably already have Excel or some equivalent, right? Whether it be the Mac equivalent, OpenOffice, LibreOffice. I mean, you might be a glutton for punishment like Greg over here and open CSVs and VI. I mean, mad respect for that. But it's kind of hard to be like an InfoSec graybeard and not use VI in a typewriter. I mean, I grew up on VI. My Linux professor, if she caught us using anything besides VI, she'd kick you out of class for the day. So it's like, whoa. With ELK. ELK is Elasticsearch, Logstash, and Kibana. It's an open source SIM. There's a few ways you can go about it. You can install it on your own host with Docker. You can install it manually. 10 of 10 do not recommend. You can also do the free trial, which is what I did, which would be hosted by Elastic. I will caution you with that, though, after you're out of that free trial period. If you ingest a lot of data to it, like, I don't know, a couple dozen honeypots on the public internet, even though it's only supposed to cost you $50 a month, by the 13th of the month, it may cost you $375. Be cautious of that. Or just don't connect honeypots to ELK. That's probably a better idea. Or at least one that you're getting charged for. So that's one thing you do want to be a bit cautious of when it comes to ELK. With ELK, though, I mean, it can integrate with other event data, as any other SIM can, because you can ingest log data, you can ingest data from other sensors, so you're getting it from hosts, you're getting it from servers, you're getting it from network devices, and then you've got all of this on top of that, so you can look at it from a multi-layered approach depending on the filters that you set up within your analysis method. A lot of other tools work with ELK. I mean, you can dump ELK stuff directly into MISP, into OpenCTI. You can use the Hive, Cortex, all sorts of other things if you want to do more of the threat intel, threat hunting stuff. ELK's not bad, but I'm not going to tell you that it is the absolute solution that you must use it. If in your professional environment you use QRadar, great. Use Splunk, sweet. Graylog, have at it. You don't use anything? No comment. Use something built in-house? Go for it. So finally we have Jupyter. Jupyter Notebook, basically the term Jupyter is a portmanteau of Julia, Python, and R. So those are three languages commonly used in data science, right? Data scientists love using Jupyter. I'm not a data scientist, but I also love using Jupyter. Because when I write stuff in Python, if I do it in Jupyter, I can get that immediate gratification. And if I'm trying to debug something, it just immediately tells me it's in cell 3, line 2, as opposed to me having to put a bunch of print. It works number 1, it works number 2, it works number 3 to find out where something breaks. It also works because you can also set it up and multiple people can collaborate on the same notebook at the same time, because you're doing it from the browser as opposed to from the command line. So that works out as well. You can also bring in various libraries, things like Matplot, Seaborn, and other well-known libraries to be able to create pretty graphs and do other things that may enhance your reporting. Because at the end of the day, when it comes to anything, right, whether we like it or not, working in information security, at the end of the day, we work in intelligence. Some of us are in OSINT, some of us are in HUMINT. Some of us are in, I don't agree with this acronym, but TechInt, I guess. It's a formally recognized one, but I don't necessarily agree. If you're on the red team, you're probably into, I would say, some SIGINT. We all do intelligence. The purpose of intelligence is to assist in decision making. How do we do that? Looking at the intelligence cycle, it is through report dissemination. Everything we do, we need to do with the purpose of, in some way, shape, or form, it being put into a report. Could be a formal written report, could be a verbal report, might even just be a JIRA ticket. It may be a, hey, Greg, the boss, come over here, take a look at this, right? Oh, I said the boss, and here comes Win. Spoken like a true manager. But anyway, it will be reported to someone for the purpose of decision making, right? And this is a little bit of the social engineer in me speaking, but some people learn by seeing, some by hearing, some by reading, and some by doing. With our reports, we can accomplish 2 of those, right? By reading and by seeing. So using something like Jupyter, same thing with ELK, it can create some really pretty graphics that we can put into our report and look like graphic design, maybe opening acts for rock stars. I don't know if I would go like rock star level. I mean, I don't know how many of you are like into hard rock and metal. I don't know if I'd put them on the same stage as like maybe Gojira, you know, French band. But yeah. Either way, so to that end, the other thing with Jupyter is you can reuse the same notebook. So you have the same CSV in, you say, I want to look at this IP address. You go through, you can have all your queries pre-built, play button, play. Here's all the data, extract it, put it in your report. Oh, here's this other IP address, play. Oh, well, I want to get some statistics. Change it to this, standard deviation, max, mean, minimum, whatever. Number of occurrences, whatever you want. You can get all of that out of there and just continue to replay it over and over and over again. Can you do the same in ELK? Yeah, it's a little bit more tedious, but you can do it. Could you do the same thing in Excel? Absolutely. Can you make pretty graphics in Excel? Absolutely. Should you not use Excel? I'm not telling you what you should or shouldn't use. I'm just trying to tell you these are the things that are on the table, and I'm openly admitting that I personally have a favor for Jupyter, but I know that's not for everyone. So let's take a look at how this kind of would gel together. So I've got another recorded demo here. So this is starting with ELK. So this is part of my, at the time, 14-day free trial of ELK. So you see, I say upload a file. So I'll drag and drop a file. There we go. So it's just showing it to us. As we scroll down, we see everything's going through. We see the number. We tell it to import. We have to give it an index name. In this case, we need to give it like Netflow hyphen something. Anyone in here familiar with the SANS VM called SoftElk at all? A couple? So SoftElk, it's a SANS forensics VM running ELK. The only thing is, it's not particularly a big fan of you just uploading a CSV as NetFlow. It wants you to send it to it from another host through the official way. So that's the reason I didn't use SoftElk, but you could use that in a production environment if you're so comfortable. So we're just waiting for the data to upload. Should be relatively quick. So now it's creating the data view, and now we can actually take a look at it. So as we go through, this is going to show us all of the data. So as we look at that, I mean, do you all agree that this looks just like the headers of a PCAP? I mean, aside from the actual content, whether it be decoded, decrypted, or just displayed, I mean, it just doesn't have the payload, right? That's more or less what it is. So this is what we have to operate off of. So as we go through this, though, we can go here and start building dashboards. And managers love dashboards. Don't you, Win?
Management board.
Yes. So right here we can say, how many top values do we want to see? And then I always cut the other out because it changes the inflation. It creates an artificial skew. So right here, if you were doing a thread hunt of these hosts, which one would you be the most interested in taking a look at? Would you even have to ask your client what is considered normal? Obviously, some exceptions do apply. This was the malicious host, but there are situations where it could have been, it's supposed to be the chattiest host. So we've got that one. Oh, here comes another one. So now we're going to find out the top destinations. That was the top sources. So that's who's initiating all the conversations. I guess that's the Joe Gray of everything, the host that never shuts up. I mean, I own it. So now we can find out about ports. I'll say that in here, doing the ports, that kind of gets a little tricky because it tries to add up all the port numbers together. And, you know, to drop a Borat reference, that's not very nice. So here we can see, ooh, this is a good one. You know that data exfiltration of a large file, or you know that occurred, or you know that someone downloaded a large piece of malware and it is moving through your network and you want to find out who patient 0 is, right? What we see right here, the number of octets, that is the file size, that's the size of your transactions, right? So with this, if we know that the average is 114,000, reasonably speaking, if we're dealing with a large file being exfiltrated or a relatively large malware file being downloaded, you know it's probably not 114,000 bytes. That's a pretty safe assumption, wouldn't you think? So, continuing. So we've got all these like cool charts and stuff that we can look at. You know, management likes it. Oh, now we're to Jupyter. So that's pretty much ELK. What I might recommend is if you're running your own ELK instance, you might want to go and take a look at SoftElk and see what dashboards they have and work to recreate them. The field names from Silk do not match traditional NetFlow field names and do not match those that SoftElk would recognize, you would need to go into the CSV and manually edit that. But that's a relatively easy thing to do. You do it once and then copy and paste it from there. You're good. But from that lens, that's the one thing you would need to do. But again, Splunk, other platforms, you can do the same thing. It doesn't have to be Elk. It was the right price at the right time for me. But that's something you could do. With Jupyter, I'll show you the actual demo piece, and then I've actually got a live Jupyter instance running with everything loaded. So this is basically what it looks like. So like right here, we can see that, like right here, the destination IP address .unique:4, that's going to tell us the 4 most talkative hosts, destination hosts. You remember when I was comparing with PCAP and I said it's hard to perform statistic analysis and find out who your top talkers are? This is a lot easier than trying to count on your fingers and toes in Wireshark, isn't it? And it takes you, to accomplish this, counting the RW commands, I think we might be at maybe 6 minutes of time expended for this. So you're probably good to go. So we know the top talkers. Right here, we can see, from a statistic perspective, we know that the mean number of octets in this one is this incredibly large number, right? So that gives us an indication of what we should be looking for in terms of deviation from that. This is a time that, if you think back to like high school level math, compare the median to the mean, and then also factor in the standard deviation as well. That's going to speak to how much variation exists. From here, you've got your value counts. So this is your frequency analysis. This tells you how many transactions occurred with each host. So that whole level of determining what is considered normal, this is it. And then going back, just playing with it, this is showing going back to elk. So there's your average, there's your median. Seeing that level of disparity between an average and a median, what are 2 things that come to mind in terms of why those numbers would be that variable? Any ideas? Here's 2 things that come to mind for me. Something's probably very aggressively beaconing or pinging something across that network, creating very small file sizes to get a median. But then you've also, on the opposite end of the spectrum, you've got something large being moved around as well. That's why you're going to have that level of disparity. So that's more or less like the type of analysis you could perform here. This right here is just your standard. This is the same Jupyter notebook, and with this, I've got it to where we have the value counts. So I've already pressed play right here, run on everything, so I don't have to run it again. But this can tell us, how many of everything exist. So in this case, I'm going to change it unique to 4 again, and just press play. So we have 4. Oh, your manager was impressed. They want to know the top 10 now. Cool. I got you, boo. That's all it takes. Standard deviation, well, you can also go a little bit further than that, right? Oh, well, yeah, I know that's how you paste. So now we've got all of these measurements that we can take a look at as well. And it's only showing us one. Thanks, buddy. But the point still stands. You could use any of these with it. There's your value counts again. Hey, there's your ports. Value counts on ports. 443 is the top one. Does that surprise anyone? Shouldn't. Ooh, 500, that is number 2, though. Should that be surprising? If you would have asked me before March 1st of 2020, I would have said, yes, this is very surprising, right? Depending on your architecture. Port 500, VPN, right? That's what I'm getting at. So pre-COVID, the use of VPNs was pretty much restricted to certain hosts and people that may have had a telework agreement. Post-COVID, it's a lot more common. But even with that, what VPN implementation do you have? Are you using HTTPS VPN or a TLS VPN or ISA AKMP, whatever. So the fact that it's number 2, that could be telling, it may not. It depends on, again, what is considered normal. So with that being said, to round out the conversation here, from here, because you've already got that Jupyter notebook, you can just immediately drag and drop or import your other tool. You can import your script for Shodan. You could import your API key for Census, or dump things out into a CSV or a JSON file and drop it in ReconNG or Spiderfoot or Maltego. You've got the ability to create those graphics for threat intel reports. You have actionable stuff that you can pass to a threat intelligence team beyond, hey, it's this IP and this port. That's great, but I need some context. Could I have a crumb of context, sir? Right? Goes into your reports, and it's going to help you look like a rock star. Merci beaucoup.